Chapter 13. Exploiting the ICMP Protocol.
The unauthorized reproduction in whole or in part of this publication in any form is prohibited.
In this chapter, we will get to know how the ICMP protocol works. Let's start by learning about the basic tools, ping and traceroute. We'll look at the useful option of the ping program and see how they work. Thanks to the parameter -c, -s, and -t, it is possible to determine the number of ICMP packets sent, as well as their sizes and time to live, or TTL. As we can see, after determining the lifetime of packet number 2, we see the information we need on the screen. After investigating the route of the packet with the traceroute program, we discover why the packet has been rejected by the second node, radio. We can now test the option that will be helpful during the DOS attack. The first of them is the -I option, which determines the packet sending interval. Another option is -F, which causes flooding with large number of packets. This option is available only to the system administrator. As we can see, within less than a second we managed to send 10,000 packets. But let's try to improve our performance using a specially prepared program. We will now copy the files we need. Our program uses raw sockets to send packets. After properly filling in the IP and ICMP structures, the packet can be sent. We will find the description of the specific structures in the header files. Finally, after having filled in the structures, it is possible to create a raw type socket using the socket function. We will now check the functioning of our program. We should remember that to create a raw socket, administrator privileges are required. Each dot printed on the screen represents one sent packet. Let's save the output of our program and count the number of dots in the program. As we can see, within approximately 5 seconds we had managed to send almost 400,000 packets. Now let's consider the ICMP protocol for other purposes. This protocol is often used in backdoors. Let's have a look at examples. As we can see, the sending of the ICMP packet generates significantly fewer suspicious records in the NetStat program. To a hacker, this is a huge advantage. Now, we'll unpack and compile the netcat program that will transmit data in the next example. Our backdoor will create a raw socket that will analyze the packets being received. When it intercepts two packets differing in size by 1,337, it will start up the netcat program. As we can see, after starting up the backdoor, the NetStat program indicates the presence of only the raw socket. After having sent two ICMP packets differing in size by 1,337, a netcat application has been started that enables access to the shell.
Unfortunately, the connection with the shell is visible at first glance. To prevent this, we will use our next program. The client program will send a properly prepared ICMP packet containing the password and the name of the file to send.
While the server program, after registering an appropriate packet, will send the indicated data in the answer. Let's compile our programs and see them work. We have been successful. The server returned the content of the indicated file. This time the NetStat program has indicated the presence of only the raw socket.